Hello, you are most welcome. I'm teacher Ivan from Wunna Educational Services. I welcome you to our next lesson. In this lesson, we shall be looking at density. Density is a derived quantity. It's derived from mass and volume, and therefore we shall get the definition of density as the density of a substance is the mass per unit volume of that substance. Density is mass per unit volume of a substance. And from that definition, we get two things. We get its formula and its units. We start with the formula. The formula of density from the definition is therefore mass over volume, because the word per unit volume meaning that we are dividing the mass over 1 unit of volume. So similarly, density means the quantity of matter contained in an object per 1 meter cubed, or the mass of an object that occupies a volume of 1 meter cubed. That's density. Then from that, we also come to the SI unit of density. Still from the definition, which is mass per unit volume, and the formula, which is mass over volume, therefore, the SI unit of density is kilograms per meter cubed. Kilogram per meter cubed, because mass is in kilograms and volume is in meter cubed. And since we are dividing mass over volume, therefore it becomes kilograms per meter cubed. Then apart from kilograms per cubic meter, we also have other units of density. That is grams per cubic centimeter or grams per cc. That is other units for density. Then we look at the uses of density. Density has various uses. Density can be used in identifying materials. You know that each material has a specific density. For instance, water. Pure water has a density of 1,000 kilograms per meter cubed. So we can identify water from its density, which is already known. The other second use of density is that we can determine the purity of a substance. Still, I will use water. If you measure the density of water and it is either below or above 1,000 kilograms per cubic meter, then that means that water is impure. It has impurities in it. So we can use density to determine the purity of a material or substance. We can use density to identify the substance or the material. We can also use density in finding volume of a substance. For instance, I have water in my tanker. How do I get the mass of that water? I will use the capacity of the tanker and the density of the water to get the mass. Similarly, I can also get volume of a substance if I know the density and its mass. So that's another use of density. Then lastly, maybe we use density in choosing the gas to fill the balloons. You know that we normally use the lightest gas. So how do we determine the lightness of the gas? By using density. Those are the uses of density. The other thing that we need to know about density is the factors that affect the density of a substance. There are three major factors, or four. To start with is temperature. How does temperature affect density of a substance? This is how it does. We know that density is mass over volume, but mass is constant, it does not change. Therefore, the major factor of density is volume. And once you change volume, the density will change. This is how it is changed. You know that the volume of a substance can be affected by temperature. When you heat a substance, its molecules gain kinetic energy and their speed increases. So increasing in the speed will lead to increase in volume. As they are moving, the substance expands. Once it expands, the volume increases. And since volume is since density is mass over volume, increase in volume will reduce density. Therefore, that means that the increase in temperature leads increase in volume, which leads a decrease in density. When you increase temperature of a substance, it expands, which leads to increase in its volume, but the increase in volume reduces its density, simply because from the formula of density, which is mass over volume, we see that density is inversely proportional to volume, and therefore increase in volume will reduce the density. So that is how temperature affects density. Increase in temperature increases the volume, which reduces the density. Then the other factor is pressure. However, pressure only affects density for gases, because gases are compressible. So when you exert a pressure on a gas, its volume reduces, which increases its density. Meaning that the increase in pressure on a gas reduces its volume because you are compressing it, which increases its density. Remember, increase in volume reduces density, decrease in volume increases density, because density is inversely proportional to volume. So that is how pressure affects density of gases. Then the other one is the concentration of atoms in a substance. Certain materials have atoms that are closely packed together, and therefore the more the number of atoms, the higher the density of such materials. So for materials whose atoms are closely packed together, they have higher density compared to substances whose atoms are spaced or loosely packed together. And that's why solids are more denser than liquids and gases, because of the package of the atoms in the solids. The other factor is the change in state. As the substance changes state, its arrangement of molecules is disrupted or disorganized. So when a substance changes its state, its volume changes, And change in volume will definitely change its density. So those are the factors that affect density. However, the size and shape of a substance does not affect its density. Reason being, the arrangement of the particles or the atoms or the molecules in this substance has not been affected by its shape or size. So we must take note of that. Otherwise, that is our first lesson on density. So please subscribe, hit the bell such that you don't miss out on any of our lessons. I'm Teacher Ivan from Wuuna Educational Services. I humbly request you to please subscribe to all our YouTube channels. That's what you can do for me, because these lessons are free of charge. But to me, they cost me a lot. So do me one thing, subscribe, share, comment, like, such that we learn together as we enjoy together. I'm Teacher Ivan from Wuuna Educational Services. We have a variety of channels. Just go to our homepage, scroll down, you'll see them. Subscribe to them. We are also on Facebook under the names of Wuuna Educational Services, Wuuna e-learning platform, Wuuna Math channel, Wuuna Kids platform, and the Teacher Ivan's online class. So please join our Facebook groups, follow our Facebook pages, such that you receive daily revision notes and questions concerning different topics at different levels of learning. We are on TikTok in the names of Wuuna Educational Services, Wuuna Kids platform, and Learn Physics with Wuuna, where we post learning videos. So please like us, follow us, and we learn together as we enjoy together. Otherwise, see you next time. Bye bye.